Hello and welcome. In this video, we're going to be talking about how to simplify radicals with index numbers higher than 2. So in this case, we're actually going to be simplifying the fifth root of 64 x to the 18th y to the 10th. So before we begin, let's just talk about radical expressions for a second. So if we start, imagine I have the cube root of 8. What does that mean? Well, literally, I'm looking for the number whose cube is equal to 8. What do I mean by cube? Well, literally, I'm looking for a number that when I multiply it by itself, and then when I multiply it by itself again, I get 8. So I'm looking for that mystery number. Well, one way to see it is if I take 8 and I factor it. Well, one way to factor 8 really is 4 times 2, and then I can factor 4 down to 2 times 2. And notice I've kind of just figured it out. So the cube root of 8 is really just the cube root of 2 times 2 times 2. And notice I figured out, okay, well if I take 2 and multiply it by itself and multiply it by itself again, I get 8. So the cube root of 8 is literally just 2. Okay, well how would this apply if I've got variables? What's the cube root of x cubed? Well, I'm going to start by factoring out x cubed. So x cubed is nothing more than just x times x times x. So the cube root of x cubed, well, I just figured out that if I take x and multiply it by itself and then multiply it by itself again, I get x cubed. I get what I started with. So I'm just left with x. Okay, well how would this work if we simplify an expression that's a little bit more involved? So if we look at number 3, for example, when I look at the inside, again, it's a cube root. So what I've just discovered for number 1 and number 2 is that for every 3 factors, what the cube root does is it basically takes one of those 3 factors. So here I've got the cube root of 2 times 2 times 2. That means I'm going to get 2 from that. In other words, I can pull a 2 out. And then when I look at my x's, I've got 3 factors of x. That means I get x out of that, or I can pull an x out. So the cube root of 2 times 2 times 2 times x times x times x is just 2x. Okay, well what if I don't have a cube root? What if I have a fourth root? Well then, instead of making groups of 3, I'm going to be trying to make groups of 4. Because for every 4 factors of any particular type, the fourth root is just going to take one of those 4 factors. So if we look at this guy, I've got y times y times y times y. And so the fourth root of that is just going to be y. In other words, for every 4 factors, I can pull 1 out. Okay, so let's see how that would apply to the problem that we had. So the first thing to notice about the problem that we had is that you've got a number underneath your radical of 64. 64 is a number that can be factored. So our first step is we want to factor the radicand. I want to factor what's underneath that radical. So 64, well, one way to break it down is 8 times 8. And then 8 I can break down as 4 times 2. Same thing with this 8, 4 times 2. Can't break those 2's down further, but 4 I can break down to 2 times 2. Same thing with that 4. Can't break those 2's down any further than that. So what I'm left with when it comes to 64 is that I've got the fifth root of 2 times 2 times 2 times 2 times 2 times 2. I've got 6 factors of 2. Okay, then I've got x to the 18th. So I'm going to write all of those x's out. So x times x times x times x. And then I'm also going to write out all those y factors as well. So I've got 10 factors of y. Okay. Step 2 then is I'm going to do basically what we did before. So step 2 is I'm going to use my index number to tell me how many factors it's going to take for me to pull one out. So step 2 is just to simplify the radical. And I'm going to put use index number. So you'll notice in this case my index number is 5. What that means is it's going to take 5 factors in order for me to pull one out. So let's start with the 2's. So the question is, how many groups of 5 2's can I make? Well, I've got one group of 5 here, and then I have the 2 left over. That means I can pull 1 2 out, and I've used all 5 of those 2's in order to pull 1 2 out, and then there's still a 2 left over underneath my radical. So I'm still going to have a radical, fifth root of, and there's still a 2 stuck underneath. Okay, so let's look at our x's. So I'm trying to make groups of 5, so the question is, how many groups of 5 can I make? Well, I've got one group of 5, 2 groups of 5, 3 groups of 5, and then I've got 3 x's left over. So from those 3 groups of 5, that means I can pull out 3 factors of x, so I can pull out an x cubed, and then there are 3 factors of x left underneath my radical. If we look at the y's, well, I can make one group of 5, 2 groups of 5, and there are no y's left over. So that means I can pull out a y squared, and I don't have any y's trapped under the radical expression. So this is my final answer. Okay, so here's another one to try. Notice it's a 4th root this time. So pause the video. After you've given it a shot, restart the video and see if you have the process down. Okay, so our first step is we want to factor the radicand. So 81 factors into 9 times 9, and then each of those 9's factors into 3 times 3. Can't go any further than that. So our radical becomes, we've got the 4th root of 3 times 3 times 3 times 3, and then I just write these out, and eventually there's actually a system that you can use, there's a process, that you can use where you don't need to write all of these out, but when you're first starting, I think it helps. I think it just helps to see what you can pull out and what has to stay. So notice this time my index number is 4. That means I'm going to need 4 factors of each type in order to pull one factor out. So if we look at our 3's, notice I've got a group of 4. That means I can pull a 3 out. If we look at the y's, I've got a group of 4. That means I can pull a y out, and then there's still going to be a y left underneath. Z's, let's see, I can make one group of 4, I can make 2 groups of 4, so that means I can pull 2 factors of z out, and then there's still 2 factors of z left underneath. So this would be our final answer.